Okay, today is February 17th. We're finishing this packet that we started on Friday. You've already done A and B. I'm going to flip it over, and we're on letter C right now. Please write down all these steps as we go. Okay, it's important, really important. I want to do C first because we're going to be writing this equation, this model for a cosine curve. And it's just a good reminder of what we did on Friday. So a weight is attached to the end of a very long spring, which is oscillating up and down. So you can imagine in this room, I have a spring attached to the ceiling. It's a very long spring, and I'm going to pull it down, and then it's going to suck itself back up and go up and down. It's a very long spring, and so it can do that for quite a long time versus a short spring, which might just go dink and then be done. Okay, so this is a very long spring. It has a lower, there's a whole like spring constant of, anyway, all right. As it bounces, its distance from the floor varies sinusoidally with time. Now, I talked a little bit about this, I think, in the video. Sinusoidally is a word that we use for any sinusoidal motion. Any motion that looks like a sine or cosine curve. They are the same thing. One is just shifted over a little bit, okay? So whether we write a sine function or a cosine function doesn't actually matter. By hand, it's easier for us to write cosine curves. They're easier to identify, typically. All right. When your stopwatch reads 2.5 seconds, the weight reaches a height of 40 centimeters above the floor. Well, that's like an ordered pair. So I'm going to start making a sketch of this. On one hand, I have the time. And on the other hand, this y, vertical axis, I have the distance from the floor. And so it says at 2.5 seconds, now I don't know where it starts. All I know is that right now at 2.5 seconds, it is 40 centimeters above the floor. Oh, yeah. So at 2.5 seconds, I know that it is 40 centimeters above the floor. So that's like an ordered pair, and it's a point. Do I know anything about where it was at 0 seconds? No, I know nothing about 0 seconds. Okay, all I noticed was that at 2.5 seconds, that weight was at the lowest, or at the highest point. All right, and then it says at 3.75 seconds, it reaches a height of 12 centimeters above the floor. So at 3.75 seconds, it reaches a height of 12 centimeters above the floor. Okay, so here we are at 12 centimeters, and at 3.75, we're at 12. So I have a maximum value and I have a minimum value, and that's really handy. So my question for you then, we want to make a sketch of this function over 2 periods, labeling each maximum, minimum. And that's really all we care about, maxes and mins, are all we need to be able to write an equation by hand. And so here we have this very leading question. When will the weight be 40 centimeters above the floor again? When is it going to get back up here? At 5 seconds? How do you figure that? Yeah? I hear different things.
I'm going to say 2. My answer is C.
1.25. What do you mean 1.25? You add, okay. So very good. Now, okay, so let's talk. If it takes, we start here at 40 centimeters high, it's taking how long to get to the minimum? 1.25 seconds to go from high to low. Does it stand to reason that to go from low to high, it would take another 1.25 seconds?
Yeah.
Okay. Maybe.
Yeah.
And
I think it would be At 4.375 seconds.
Nope.
Oh wait, actually maybe not.
All right. So again, if it takes 1.25 seconds to go from a maximum to a minimum, then it's safe for us to assume, because this is an exceptionally long spring, that it's going to take another 1.25 seconds to get back to the maximum, which puts us at 5 seconds. Okay. So 5 seconds. We just made one complete cycle of our curve. High, middle, low, middle, high. What kind of curve is that? A cosine curve. That is one period. That is one period of our cosine curve. But we want 2 periods. So when is it going to be at the minimum value again?
Another 1.25.
Another 1.25 or 6.25. And then when's it going to get to a maximum again?
A little bit later.
7.5. Very good. All right. And so now we've graphed that weight bobbing up and down over a period of time. Okay. Very good. So some good logic there. And now we need to use this picture. This is why having this picture is so useful. To write this equation, which that model, y equals a cosine bx minus c plus d. So we're going to write a model for this curve that we've drawn. And the first thing we're going to do, you guys did last Friday. What was the first thing that we found? D, the midline. All right, the D value, to figure out D, how do you find D?
It's minus 2 plus 1/2 low plus high.
Half of the lowest value plus the highest value. So when we look at our graph, what is our lowest value? 12. What is our highest value? 40. So when you add those together, you get 52. What's half of 52? 26. All right. So our D value is 26. And you can imagine, does 26 seem about right for a midline?
Yeah.
And you can look at it and see it. Yeah, it looks pretty good in between there. What's the second thing you find once you found the midline? A or amplitude? Amplitude. The amplitude is always positive because it's amplitude, all right? The A value is very different. That value could be positive or negative based on the picture we have. So amplitude is easy to find. It's just high minus the D, high minus the midline. So in this case, that's 40 minus 26, which is 14. All right. So that's the amplitude. And amplitude is always positive. What is your value for A? Why does it stay the same?
Because it is still.
It's not a reflected cosine curve. It starts up high, middle, low, middle, high. And so this is a regular cosine curve, all right? So our A value is remaining positive 14.
So are you saying that, like, if it was one of those
If it was-
negative ones,
Yeah.
then A would be the negative
Negative.
version of that?
Mhm.
Okay.
Yeah.
So it's always going to be the same number, just
Yes, the sign.
positive.
Yeah, A can be positive or negative based on our picture. So this is a regular cosine curve, positive cosine curve, so we keep it positive. All right, quiet please. What do you find after you find the value of A?
The meaning of life.
The period. Okay, so we need to find the period, and this is the length to complete one period. So here is where we are starting And here is the end of our curve. We're starting at 2.5 and it ends at 5. So how do you find the period? You subtract them. Ending minus starting. 5 minus 2.5 is 2.5. That's the period. Period doesn't show up in this equation. How do we use period?
To find B.
To find the B value. So to find B, how do we figure out B?
2 pi over the
2
period.
pi divided by the period is how we figure out B. And so we have 2 pi divided by 2.5. And normally, I would say never leave a decimal inside of a fraction because that's just a complex fraction and we always simplify. But I'm going to say forget about it and leave it.
Yeah,
Okay.
bad.
All right. What is the last thing that we should do? Find C. So where does C come from? Yeah. So when we were graphing, we would take everything inside with x, and we would set it equal to 0 and set it equal to 2 pi. And well, I just need one of those equations to figure this out. And so we can pretty easily move the C over. So it turns out that C is B times X. B, we just found. So B is 2 pi divided by 2.5. And what does X represent? Your starting X value for your cosine curve. And our starting X value was right here. Started where X was 2.5. And so we're just going to plug in 2.5. And what happens?
Those two cancel down.
Yeah,
so
those go away. That's nice. And we're left with 2 pi. How about that? And so that's our value of C. And now we just get to plug everything back in to our model. All right, so I have a model of y equals A was 14. This is our cosine curve. B was 2 pi divided by 2.5. So I'm going to say 2 pi x on top divided by 2.5. Don't forget the x. Minus C. C was 2 pi. And then plus D, which was 26. So I'm literally just plugging in my A, B, C, and D in my equation. We want to double check this. So I'm going to make sure that my calculator is in radian mode. And I'm going to plug in my equation. And that's why I put the X on top. The Casios have a little bit of an issue with that. So 2 pi x on top divided by 2.5 minus 2 pi plus the 26. Now, here's the important part about checking your equations. The best thing to do is set your window so that it's identical to the window that we graphed. So I'm going to go to my viewing window, and I want my x-axis to go from 2.5 to 7.5. It doesn't really matter what the scale is. And I want my y-axis to go from 12 to 40. And again, I don't really care about the scale. So I should literally just see these curves. Right, and then hit graph.
What'd you set for the X maximum?
I went 2.5 to 7.5 for the x min and max. And for the y min and y max, 12 and 40.
Okay, thank you.
And a lot of these we could double check. So I could pick a value like right here. This is the ordered pair 6.25 and 12. So I can trace and type in 6.25. And there's Tinkerbell, and she gives me a 12. So I know that our equation is perfect. Okay?
Minus 50.
Okay.
What do you put for the X scale?
It doesn't matter.
I got straight.
You don't have an x in your equation, or you're in degree.
The 1.6.
All right. Let me know if you didn't get the graph right now. Who needs help?
Can you go back to that other screen?
The window?
I keep it's weird. It says the division.
Wait, next. So the window. Type in that.
Mine's not a roller coaster.
All right, very good. Okay. So, very good. Seems like you remember how to do this stuff from yesterday. That's excellent. So let's go and look at letter B. Ladies and gentlemen, this particular example is exceptionally important because this is your next project.
Yay! Graphic. Easy.
You what?
Yes.
All right. So you will get your next project. I have to decide the due date for that. You guys can help me out with that.
Next year.
Okay. The project should be grade boosters. So you don't not want to have it, okay? All you have to do is do exactly what we're doing here and then put it on a poster. Okay.
Copy and paste.
So 29.7 represents the average monthly temperature of Denver, Colorado, starting in January. So, whoa. Sorry. All right. So this is 1 represents January. And what we want to do very first is actually repeat January again as month numbered 13. And I do say this in your rubric. So we're going to repeat January just so we see that repeated value indicating we started at 29.7 and we're going to end at 29.7. So we have that repeated value. That's 1 complete period. Okay? Because a period is when it starts to repeat itself. These are the average temperatures. And what we want to do is we're going to draw a scatter plot by hand. Now, you are not going to draw this scatter plot by hand. You're going to use Desmos. Okay? And so in Desmos.com, there's a little plus symbol right above where you enter equations, and then you'll be able to enter in the data just like this. All right? And it'll graph everything. You can also change your window to match your data. We don't want to see everything from 0 to 100. We only care about 1 through 13, okay? And that little window settings tool is the little wrench, all right? And so if you go to the wrench, then you can change your window so that we're only looking at the data we care about, okay? So we're going to start by plotting these by hand just for fun. So go ahead and take a second and plot this data. All right, so by definition, this is a scatter plot. Do you connect the dots? No. What does it look like? A cosine curve. A cosine curve, yeah. You can see we have 1 period, starts at 1 and ends at 13. We have 1 whole period starting to repeat itself, which is why we repeat that January month again. And so we have our starting x value at 1 and our ending x value at 13. And that's representing 1 period here. Okay, so now that we have a picture, we can go again through our process to write the equation of the curve. Oh, before we do that though, here we have some calculator stuff you're going to be doing. We want to enter the data into stat in your graphing utility. So if you have a TI, you have a stat menu. If you have the Casio, go to your menu and find the statistics menu
We get a phone in.
All right. So, yeah, on the Casio, it's so easy.
Yeah.
On the TI, it sucks balls.
So which one?
Let's go
am I using?
Casio.
All
Like hot 1, 2, 3, 4?
All right. So we are going to press stat, and you see this menu. You guys don't. You see your list right away. And then we do number 1, edit.
Wait, mine is like that.
Numbers.
Okay. Did you press stat? No, you just press stat.
Oh.
Press stat.
I can't spell what the buttons say.
Why? Okay. All right. So the directions say enter data into stat : edit. So that's stat and edit. And so you should see L1, L2, L3. Now I have data in mine. I want to clear that data, so I move my cursor all the way to the top and do clear and enter. Do not press delete. Clear and enter clears your list. Okay. So what we need to do in list 1 is you're going to enter in months 1 through 13. And in list 2, you're going to enter in all the temperatures. All right, do it now. All the months 1 through 13, and then all the temperatures in L2. All right, you've entered in all your data. First things first, you need to double check that they end at the same place. You have 13 entries in list 1, and they end at the same place. They're not mismatched. If you had an extra number or you forgot one and they didn't line up, then you're going to get a mismatch error, okay? And that's because they didn't line up, all right? Now, you've entered the data. You can actually view the data in your calculator as a scatter plot as well. So to see scatter plot, if you have a Casio, you have a menu button that says graph. Press graph. It's F1.
Oh.
Then it says graph 1, graph 2, graph 3,
Yeah.
Graph 1. Mm-hmm.
Oh.
Okay, so super easy with the Casio. Press graph and graph 1. For the TI, you're going to go to y equals. I'm clearing out any equations that I have in there. And you need to highlight plot 1. That turns on the scatter plot. So you see plot 1 up there? Move Tinkerbell, move your cursor up there and hit enter so that it's highlighted. Highlight plot 1. And then you need to do zoom stat. So you press zoom and go down, 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 down to zoom stat. Zoom stat. And then you can see that it'll plot the graph for you. Okay? You can change that. Yeah, if you didn't want squares, you could change those, but it's not necessary. Okay. All right, so here we go. Let's find our equation. So just like before, the first thing we're going to do is what? Find D. How do you figure out D? 1/2, low plus high. And you're writing all this down so you can basically repeat on a poster for me later. For 30 free points, you copy what exactly we do here.
That's awesome.
Okay.
I love it.
The lowest value, again, we can see from our curve, our lowest value is 29.7. Our highest value we can see occurred in the 7th month right here, high of 73.5. So 73.5.
That's what it said. No, that's awesome. I wish I was in Denver right now.
And then I'm going to use my calculator to add that up because I, just can't. So 0.5 times 29.7 plus 73.5. And yeah, 51.6. So that is our D value. 51.6. Okay? Then the second thing we can do is find the amplitude. This is amplitude, which is different than A. Amplitude is not the same. How do you find the amplitude? High minus D. High minus D. So the high value was 73.5. Our D value is 51.6. So pi minus D.
This is 73.7.
Sorry, 73.5. Thank you. 73.5 minus 51.6 was 21.9. Okay. All right, that's amplitude. What's A?
In this case, it's the same. Oh wait.
No, it's
Why is it negative?
because it starts.
Oh, because it starts at the bottom.
Because it starts low, then middle, then high, then middle, then low. This is a reflected cosine curve. All right, so please, A and amplitude are not always the same. I will take off points for that if you get it wrong. Okay, on the product. Okay, this is negative. The A value is negative because it is a reflected cosine curve. All right, then we're going to find what next? Period.
I would like you.
The period is
No, that's B.
the ending x value minus the starting x value.
My word.
So 13 minus 1 is 12. And that allows us to solve for b. How do we solve for b? 2 pi over 12, which is
5 or 6.
pi over 6. Ladies and gentlemen, it will always be pi over 6 if you do it right. Don't do it wrong. Else I'll mark you down for it.
Awesome.
Okay, and then how do we figure out c? Yeah, c equals b times x. So, for this, yes. Yes. Our b value is pi over 6. What's our starting x value? 1. So we get pi over 6 again for c.
Well, that'll also be the same for our project, right?
And that will be the same for your project. And so now we're going to plug in our A, B, C, and D into our model. Oh, sorry, that's a typo. I'm sorry. That should be a cosine curve. You're right. That was a typo. I didn't get changed. Sorry. Y equals. This is a cosine curve. So A was negative 21.9. Cosine of B, I'm going to say pi x over 6 minus pi over 6 plus 51.6. So there is our by hand model. We're going to go ahead and go to our calculators and type that in because we have a model, so it should pass pretty good through our data points. So go to y equals and type in your by hand model. Negative 21.9 cosine of pi x divided by 6 minus pi divided by 6 plus 51.6. So once you get that typed in, hit graph. It's still graphing your statistical data. So hit graph. Is it perfect?
Wait, hold. What did you hit the graph?
Graph.
Oh, okay. Not
Oh, y equals?
Oh, did you put negative?
Yeah. So is it perfect?
Something's wrong here.
No. It's close.
Because the data is the
It was a little bit hard to do. I'll have to look at it again. But you'll be able to graph the calculated equation. All right, last thing. I have 1 minute. Here we go. Now, the last thing is we also want to use this data to find the sinusoidal function of best fit from your calculator. Okay, and to do that, for Casio, it's super easy. You should see, go back to your stat menu and then calculate.
Where's that?
Calculate.
I had a different situation.
Yeah.
That's a
There we go. I finally got it.
That showed up on